For lesson 3.5, we're going to work on some math models. So using real world data and creating a math equation that can represent it. So we're going to jump in here with number one. We have median sale prices in thousands of dollars of new homes sold in a neighborhood from 2003 to 2010, and they're given as ordered pairs. A linear model that approximates the data is y equals 5.96t plus 161.3 for t on the interval 3 to 10. So t represents the year, and t equals 3 is the year 2003. So we want to plot the data and the model on the same axis. We're going to use Desmos to do this. And we're going to see how closely the model represents the data. So we want to plot these points on Desmos, and we also want to plot this equation. Now, since we're saying that t equals 3 is year 2003, so instead of 2003, I'm going to put 3, and then instead of 2004, I'm just going to put 4 and 5 and 6 and so on. So let's pop over to Desmos and check that out. So to create a scatter plot on Desmos, you're going to go over to this plus sign here, and you'll insert a table. And when you do that, it gives you this thing where you can enter your data points. Now, I already did it so that you don't have to watch me type in a bunch of numbers. But again, that plus sign, insert table, and that's how it's going to do it. So I've already got my numbers, 2003 and 179.4, and so on and so forth. And then I also have that equation that they wanted modeled there. Now, we need to go find the data, and usually we zoom out, but there's an easier way to do that if you go to your settings up here. Notice for my x-axis, my x values in this table, we could just start at 0 and go to 2015, should be good enough. And then my y-axis, I could also start at 0, and it looks like my y values go up to like 225. Oops, sorry, that's not it. Over here. 225. So we can just set the window to whatever we want, and then it's a lot easier to see. So there you can see it. That's my scatter plot. That's the equation that models them. And I would say that's a really good fit. It hits all those points, not dead on, but pretty close. So back over here, we would say, the model represents the data very well. Now, something that we use, rather than just using really imprecise language, because I used really imprecise language, we're like, oh yeah, it looks like it's good. The statisticians use something called the sum of square differences to find a least squares regression line that minimizes the difference. We'll talk more about that if you take stats next year. But what we'll do is we'll have Desmos create this line for us, and that's going to give us, Desmos is going to give us something called an R value, which is a correlation coefficient. And it's a measure of how well the line fits the data. The closer you are to 1 or -1, the better the fit. So we'll do another one like this. So number 2, we have Medicare disbursements in billions of dollars are given by these ordered pairs. So we're supposed to construct a scatter plot that represents the data and then find the least squares regression line and the R value. Desmos is going to do all of this. Now, just to point out again, I'm going to use, instead of 2003, I'm just going to use 3, and oh, that was terrible. You know what I meant. And instead of 2004, I'm just going to use 4 and so on. So I'm going to alter those ordered pairs just a little bit. So over on Desmos, again, to get this, you're going to insert a table using that plus sign, but I already did that. So here it is. And so it should create a scatter plot. Now, again, I need to go find it. So I'm going to adjust my settings, have my x-axis go from 0 to 15 is fine. And then my y-axis can go from 0, I don't know, maybe 600. Just want to make sure I can see them all. So there they are. Let's see. That scatter plot looks a little weird. What happened to that point? 2009. Oh, nope, that's right. Okay. All right, so we want to get our values. We want to get a line that's going to fit this. Okay. So we're going to have Desmos do this. So below this, you're going to click. Now remember, the equation of a line is y equals mx plus b. Okay, that's what we want. But Desmos needs to know more specifically a little more information. So notice we want it to use these values, this x1 and y1. So we're going to tell it, we want you to create this, but use x1 and y1. All you have to do is type 1 after it, and it knows what you mean. And then we don't want it to be equal to, because it doesn't. We want it to be approximate. So we need to use the little tilde squiggly guy. I just have to find it on my keyboard here. If you can't find it, Desmos has it. Oh, there we go. It's in the ABC menu right there. That's what we need. Except we need it right there. There it is. Okay. All right. So we have told the Desmos to use our y1 and x1 from the table and say it's approximately mx plus b, and it will create this fantastic line. Notice it gives us an r value right here. This is what we need. Our r value is 0.92. And it gives us the slope and the y-intercept. So notice the slope is 30.9 and the y-intercept is 187.4 or so. So we can jot that down. So now we know what the math model is. So Desmos told us it was y equals mx plus b, and they told us on there that m was 30.9 and the y-intercept b was 187.4. So that's a model that we can use to estimate Medicare disbursements for any given year. And the R value was 0.9256. And that is pretty close to 1. So we would say that that is a strong fit, that this model is a good fit for that scatter plot. So that's how we use Desmos to create these least squares regression lines. So we'll talk about the other types of variation and modeling in the next video.